All right, the next general topic that we're going to talk about is routes of transmission. So how does an infectious disease get transmitted from one person to another? In other words, how do you catch it? Okay, and so I'm going to go through this on just one slide, but there's a lot in here, so hopefully you're going to get it, but I wanted to put it all in one place. So some infections are vector-borne, meaning that they are transmitted by insects that bite you. So one example would be Lyme disease, which is transmitted by tick bites. Another example would be malaria or West Nile or a bunch of other diseases like yellow fever and chikungunya that are transmitted by mosquitoes. So there are quite a lot of vector or insect-borne communicable diseases. They can be transmitted by animals. So you might be aware that bats are often carriers of rabies. And so the reason why we haven't been able to eliminate rabies from the world is that it's naturally present in many animals. We call them animal reservoirs. And so we're constantly kind of coming into contact with these animals and they can infect us. So it could be animals. It could be airborne, and lots of infections are airborne. I have a graphic. Oh, it's coming. The other is, so airborne means it spreads through the air, right? So either I cough or sneeze and a bunch of droplets, like these kind of very small, almost too small to see, particles spew out and they have germ in them that then you could inhale, or you get in your eye or whatever it might be, then it gets into your body. Or fomites. So fomites is surfaces. So fomite is an inanimate object, right? Not a living thing that the germ can live on for a period of time. And then if you touch it and then maybe touch your mouth or rub your eye, you can infect yourself. So in the beginning of COVID, we weren't really sure if it was airborne transmission or fomite transmission. So here is the graphic that kind of shows you the examples here, right? So here is, airborne. But then, a big clump of snot, well, or not so big, lands on a surface, right? Fomites are contaminated surfaces. And then what if you touch that and then touch your eye or something? So in the very beginning of COVID, we were telling people to wash their hands a lot. We were using hand sanitizer. We were wiping down the desks. We were doing all those things because influenza, for example, is a respiratory infection, but it has significant fomite transmission. So it can live on contaminated surfaces for a while, and then you touch that and then touch your mouth or nose or eyes and you get infected. What we found later with COVID is that most transmission is airborne. It's airborne, it's aerosols and droplets. It's not through contaminated surfaces, right? I had friends who were working in COVID units who, when they came home in the beginning, they would shower and wash all their clothes and leave their dirty clothes. Like they would literally strip down, leave all the clothes they wore at work in the garage, go right into the shower. They had these little UV disinfectant things for their keys and other things that they had to touch. But then we learned that that wasn't going to be an issue, but it took us a while to be able to know that. All right. Sexually transmitted infections. So there's lots of different types of sexually transmitted infections. Some require different types of sexual activity to be transmitted from one person to another. So things like chlamydia, gonorrhea, HIV, syphilis, right? That's a great, you're getting up close and personal with somebody. That can be a really great way to spread a germ from one person to another. Then water and food. So, sometimes bags of salad lettuce are contaminated with E. coli or strawberries or hamburgers somewhere. Water, absolutely. So remember the case of John Snow and the cholera epidemic, where the contaminated well, the Broad Street pump, was the source of the cholera epidemic. So water and food can also be the routes of transmission. Fecal oral means that it's an infection that you kind of poop out, and then if some of those little bits of poop get into somebody else's mouth, then they get infected. So that is also kind of what was going on with the cholera epidemic in London, but then it got into the well and the pump. But this is why it's so important to wash your hands after you go to the bathroom, particularly if you are having a bowel movement. Now, urine is sterile. Poop is not, right? So fecal matter, stool, has lots of germs in it. Usually they're relatively harmless, but that's why you see all those signs, public health at work, in the restrooms at restaurants saying employees must wash their hands after using the bathroom. Fecal oral transmission is a problem for some things. And then there's bloodborne. So bloodborne transmission, those things in general sometimes are transmitted sexually as well, like HIV, but we see a lot of that with injection drug users. So people who are sharing needles, so who inject in their arm and then they give that needle to somebody else. So the blood gets kind of transmitted from one person to another. So the other way that bloodborne pathogens can be transmitted is through blood transfusions. And so if you've ever donated blood, they ask you a whole bunch of questions about whether you've traveled to certain regions, and then we now do all kinds of testing to make sure that that blood is safe. Finally, there's what's called vertical transmission, which is from the pregnant person to the fetus. So a woman who is infected with HIV, if she gets pregnant, she can pass the virus to her fetus in utero before it's even born. She can also end up passing it to the baby during labor and delivery and even during breastfeeding. So this kind of vertical transmission from parent to child can also occur. Okay. All right. Sorry, I had a text there. All right. So the next general principle is identifying the contributory causes. So really what we're doing here in the case of a communicable disease is trying to identify the germ. So back in John Snow's day, he was just able to identify the Broad Street pump. They had no idea that there was a bacterium called Vibrio cholera, right? They didn't know, but now we can usually identify the germ. And the way we're going to do that is by using what are called Koch's postulates, after the scientist Koch who came up with this. And so what we're looking for are the potential germs that could be causing a certain disease. Now, our potential cast of characters here, there are different types of germs. So there can be bacteria, there can be viruses, there can be parasites, and there can be prions. So COVID is a virus, for example. Strep that causes strep throat is a bacteria. The germ that causes mono, if you've ever had mono, that's a virus. Let's see, parasites. Scabies is a parasite, if you've ever had scabies. Fleas. Okay, so what are these postulates? This is kind of a modern take on them. So what are the criteria that you have to fulfill in order to say this germ is causing this disease? The first is you need to have this epidemiologic association, really a group association between the presence of the pathogen, the germ, and presence of the disease. So if you find that, well, most of the people who are having the disease also have the germ, right, then that's a pretty good indicator, but it's not enough by itself. You also have to be able to find it, so not just in those populations or groups, but in actual individuals with the disease, right? So now taking it down to that individual level. And then, oh yeah, caution here. So the word isolate gets used two different ways in public health. It's super annoying. So in this context, isolation means you can find the germ in that person. You can detect the germ in that person. In other contexts in public health, to isolate somebody means to, if somebody's infected with COVID, you keep them away from other people and you isolate them. So it's very confusing. I apologize. They didn't ask me when they came up with these terminology. Okay. And then the third is you have to demonstrate that you can transmit the disease by giving the germ. So usually we're not going to do this in people. In the olden days, they did. They were like, I think this causes smallpox. Let me give some to you and see what happens, right? Thankfully, we don't do that anymore. For the most part, we use either animals or now we'll use cell culture. So just cells that are growing in a petri dish, and we'll see, well, if I infect them, do they start behaving like the cells of somebody with this disease? So that's Koch's postulates, or how we establish contributory cause or identify the germ that's responsible for the disease. The next thing we want to do is we want to get a sense of a potential impact. how bad can this be, right? How bad can these different infections, these different communicable diseases be? The potential impact, or how bad it's going to be, is going to depend on two main factors. One is, how serious is the illness itself, right? So if you get infected, what is the case fatality rate? How many people that get infected with this die? What is the hospitalization rate? How many people don't die, but they get really sick and they're in the hospital? Or disability, right? How many people maybe don't die and maybe can get put in the hospital, but have long-term consequences or suffering or decreased function because of it? So in the example of COVID, right, we have people with long COVID now who are not in as good health as they were before. And then are there any other long-term complications? So this is less frequent. In the olden days when scarlet fever was an issue, if you had scarlet fever as a child, it increased your risk for some problems with your heart valves later on in life. There can be these weird things that happen. So that's for how serious the individual illness is, and we're going to come back to that in a minute. But next I want to talk about how contagious is it, because that's going to tell you how many people are going to get it. So when we're thinking about the impact on a population as a whole, we don't just care about how severe the disease is, we want to know how many people are going to get it, because that's going to determine the size of the impact on our population as a whole. So the way we talk about how contagious a certain infection is with the R naught. Now you notice here, contagious as a word is the same thing as infectious, is the same thing as transmissible, is the same thing as communicable. So we have like 4 different words that mean the same thing, which means you can transmit it from one person to another. It's catching, it's contagious, okay? Again, I apologize. So R naught, R with a little 0 underneath it, is the number of people on average that get infected by one infected person. So on average, for example, a person with measles, right? So here's measles. On average, they infect between 10 and 18 other people, right? So you have one person gets measles, on average, they're going to infect 10 to 18 other people. And then those 10 to 18 other people are going to themselves infect 10 to 18 other people, right? That's really, really, really contagious. Okay, whooping cough, as you can see, which is pertussis, is highly contagious. Chickenpox is super contagious. When I used to do pediatrics, if a parent was bringing in a kid that they thought had chickenpox, we would say, okay, don't bring them into the office. I will come out to the car and I will examine the kid in the car, because I don't want you bringing a potentially infectious or contagious kid with chickenpox into my clinic. HIV, if it's untreated, can have usually around an R naught of about 5 in people who are untreated. Then we see diseases that you've probably never heard about because you've been vaccinated. So diphtheria, rubella, polio, smallpox, mumps. And then here's flu, right? So not the biggest. And then here's Ebola here, right? So different germs are more or less contagious. And how contagious, or what the R naught is going to show you how it can spread. So for example, if a condition has an R naught of 2, that means on average, each person is going to infect 2 people. So you can see here, we start with one infected person, and then 2 people get infected by them, and then each of those infects 2 people, so now we have 4, and then each of those infects 2 people, so now we have 16? Yes, 16, right? And it goes on and on and on, right? So it will go 8, and then it would go 16, and it goes on and on. So let's look at the difference, though, if we dial that R naught up to 5, right? Let's look at how that goes. Bam! Right? Huge. So we go from 1 to 5 to 25 to 125. It's ridiculous how quickly something can spread if it has a really high R naught. So this is a graphical representation. Let me give you a different type of representation of the same data. So here is an example of, let's see if it takes a week to spread for a disease with an R naught of 2. You can see week 1 we have 1 person, week 2 we have 2, then we have 4, then we have 8, then we have 16, and so on, so that by week 8 you would have 120 people more infected with the condition. However, if we compare that to an R naught of 5, look at the difference, okay? So the y-axis is the same here, but the weeks only go to week 4. And look at how much the R naught of 5 has outpaced the disease with the R naught of 2. And the disease with the R naught of 2 was spreading really, really fast. Okay, so R naught is a really important number when we're talking about communicable or infectious diseases. So what impacts the R naught? Like what determines whether something is really contagious or not? Part of it is the pathogen itself, the characteristics of the germ, the virus, the bacteria. Some germs are just really, really contagious. They're really good at turning your body into little germ factories that can then infect lots of other people. So some of it is just inherent in the type of infection it is itself. But mitigation measures that we do or do not employ can make a huge difference on the R naught. So things like social distancing and masks reduce the ability of COVID to infect other people. Chlorinating our water supply reduces the ability of cholera to infect other people. So R naught is not just due to the germ itself, it's also due to the things that we do or do not do to try to control the germ, as well as our immunity to the germ. So if I have really good immunity against something, then you can't infect me, right? And so you get immunity through both natural infection, right? So having gotten infected and then your immune system learns to fight it off, and through vaccination. Both are good ways to develop immunity. In general, vaccination is a much, much safer way, a much lower risk of severe illness for most things. But what's interesting is that although your individual vaccination status or immunity status has a high impact on your disease outcome as an individual, in order to have an impact at the population level, you need to have really, really high immunity. You need to have a lot of people immune. It also ideally needs to be what's called sterilizing immunity in order to make it so that people then can't transmit the germ to other people. There's various different levels of immunity, and this sterilizing or neutralizing immunity is sometimes easy to get and sometimes not easy to get depending on the germ. And so, spoiler alert, for COVID, it's very difficult to get sterilizing immunity that lasts for any significant length of time, which is part of why what has happened has happened. Okay. So when we're thinking about how quickly something can spread then, so say I'm the public health officer for Dunn County, thank goodness I'm not, right? But say, and I want to know, okay, well, how quickly could this thing blow up and overwhelm our hospitals, for example? I want to know not only the R naught, but also what's my lag time. And so my lag time is called the latent period. So what happens is if I get infected with COVID, a period of time goes by before I can then give that COVID to somebody else. The longer that lag time or latent period is, then the more slowly it's going to spread through the population because it takes people longer to become contagious, right? So let me just kind of show you here. Anytime you get infected, right? So this line here is when you get infected. You don't start having symptoms until here, right? That's what this arch is, oh, I feel sick, I feel yucky, right? In COVID and many other things, you start becoming contagious before your symptoms start, okay? Which is tricky. Not all diseases do that, COVID does, right? So this latent period in COVID is shorter, and for many diseases is shorter than the time to disease or symptom onset. So let's take a look specifically at COVID. All right. So for the original virus, the R naught was 2.5, which is pretty high actually for an infectious disease, not anything like measles, but on the higher side, higher than influenza for sure. And the latent period was about 4 days. So let me show you what that looks like. So here's where you get infected, right here. Here's the latent period. And then starting here, you are infectious or contagious to others, right? So you're infectious starting from about 2 days before your symptoms started, right? Here's kind of symptom onset here. And then you stay contagious, really contagious for about 5 days, and then somewhat contagious out to day 10 for the most part. Now, these are averages. It varies from person to person. And not only does it vary from person to person, these are just averages, but COVID then went and mutated, right? So as things do, so we started with the original virus, and then we had the alpha variant, and then we had the beta variant and the gamma, and then the delta. And the delta variant, interesting, was more contagious than the original. So its R naught was somewhere around 3 to 6.5. And then most recently, Omicron came on the scene, and its R naught, right, the summer of 2022, and then its R naught was somewhere around 5 to 10. It's really hard to know because at this point lots of people aren't testing anymore and we don't have good data, and we think the latent period is as short as 2 to 3 days. So higher R naught, shorter latent period, so really rapid transmission. So let me show you what we're looking at here. I'm sorry, my video thing is in the way. So we're looking at daily new confirmed cases per million people. So it's adjusted per population for the United Kingdom, United States, and European Union, because they have a lot of things in common. They're very similar. So we're looking, it starts way back in 2020, and then this goes just till January of 2022, this particular one, just because I liked cutting it off right there. This is the original strain of the virus, right? And then things got a little bit better. And then we had a little blip from the alpha variant. And then we had Delta wave, and that was pretty significant. And then, oh my Lord, look at Omicron. Look at how quickly it spread and how many people it infected, right? So just like huge, huge, because the latent period was shorter and its R naught was higher. So this thing just took off like crazy. So this is looking at that region in 2 different countries. Same thing happened here in Wisconsin, just went right up really high as soon as we hit Omicron. So again, there's the original alpha, delta, and then we got Omicron right on top of our delta wave here in Wisconsin. Okay, so that is how quickly it's going to spread through the population. What's the R naught and what is the latent period? So how contagious it is and how quickly is it going to spread. Now what's going to determine the severity of the illness, right? So part of it is the pathogen itself, right? The germ itself, just like with R naught, same thing for the severity. Some germs are going to kill you, like, Ebola usually does. Rabies has a really, really high fatality rate. Part is the dose to which you're exposed. So sometimes if somebody just coughed a whole big cloud of COVID into your face, you would get sicker than if you just got a little whiff of it. So the dose to which you're exposed can make a difference. And then there are factors unique to you. So we talked about this before, right? What are our vulnerable populations? So age, very young, very old. Are you immune compromised? Are you pregnant? Do you have other medical conditions that increase your risk? And do you have immunity from vaccination or previous infection or both, right? So with Omicron, when we're thinking about what's the potential impact of the illness, right? So it was very contagious and it spread really, really rapidly, but it tended to cause less severe disease. In part, we think because of changes in the virus itself and the pathogen itself, also to a large extent because of immunity in the population from both previous infection and vaccination. But when we look at the potential impact, even though it's less severe, we can see, so now we're going to look at data for Wisconsin, that the number of people who got hospitalized from the Omicron surge was just about as high as the number of people who got hospitalized from our first winter surge. So our second winter with COVID was just as bad as our first winter, despite the virus, the variant, being less severe in and of itself. And the reason is because it was so much more contagious. So many more people were getting it in such a quick period of time that it caused a lot of hospitalizations. Even though per case it was less severe, there were just so many more cases. So it still had just as big of an impact because even though it was less severe, it was more contagious. So if we look at what's happening currently, so this goes up right till January 2023, we can see these are hospitalizations over here. We are not back down to kind of normal. We're not anywhere close to that. We're not up here which is great because that's where we've been other winters, and hopefully we won't get there, right? But we're still having significant impact from this disease. So again, when we're looking at potential impact, how serious the disease is, what's the case fatality rate, what proportion of people get hospitalized, have long-term complications, and then how contagious it is, how rapidly and to what extent it can spread through the population. So this chart is looking at R0 on the bottom, so average number of people infected by each sick person, that's the R0. So down here, R0 of 1. So seasonal flu, on average, most people transmit it to like 1.2 people. So it doesn't tend to spread very quickly, but it still gets there, right? Here's chickenpox, I told you, really contagious. Here's measles. And on the y-axis, what we're looking at, and this is a log scale, so it's kind of weird, but it's the case fatality rate, right? So Ebola is up here, right? Smallpox is up here, right? So what we see is things that are kind of, let's see, I'm going to use a different color. Things that are kind of over here, right, don't tend to cause a significant impact, right? And then once we get out here, we start to see more of an impact. And then the farther and farther we get out, we see more of an impact on the population, either because it's infecting a lot more people, and therefore, even though severe disease isn't common, there's enough of it that we're still seeing a lot, or because it's very deadly. This is the same type of chart looking at R0 and case fatality rate that just includes a whole bunch of other types of infectious diseases, which I think is interesting to look at. It's by this guy, David McCandless, who wrote a book, Information is Beautiful. It's a really cool book if you're as nerdy as I am and you want to check it out. But what I like about this too is that he used different colors to designate the route of transmission. So whether it's airborne, whether it's by animal or insect bites, body fluids, fecal, oral, food, sexual contact, or surfaces. So that's kind of cool. I like it. But the other thing that you can see out here, mumps, whooping cough, measles, highly contagious, right? And so that's why we vaccinated people against it, because now we don't see those diseases anymore, which is pretty amazing. Well, not much. We'll get to that. All right, so for general concepts, we've now talked about burden, routes of transmission, how we identify contributory cause, Koch's postulates, and then potential impact. So that depends on the transmissibility, how contagious it is, what's its R0, and how quickly can it spread through the population, what's that latent period, and then the severity of the disease that it caused. So if you do get infected, what's the likelihood that you're going to get very sick or die? All right, so that was a lot. So we're going to take a break, and then in part 2, we're going to talk about tools and strategy.